Okay, this is part 2 of that video. We had left off trying to find an expression for C sub n, and we were at this point right here. So let's continue. We're almost there, really. First, let's clean this up a little bit. Here we have I squared. So to get rid of the i's, just put a minus sign out here. So we have 2 pi. The minus sign, the lambdas will cancel. So this part is 1 over 2 pi times 1 minus 2n. And let's take a look at this one. Here we have I squared. That's negative 1. That's a negative sign, so this, we can get rid of these, and let's just leave it as it is, 2 pi. And here these lambdas cancel. So we have this. Okay, now let's go up to here. T goes from 0 to pi divided by lambda. So C sub n, so we want to make some room, so we have to do some visual footage. We have C sub n equals minus 1 over 2 pi 1 minus 2n. Then, from here, we substitute in t is equal to pi divided by lambda. This lambda will cancel with that lambda, so we're going to have e to the 1 minus 2n times I. Now here we have pi, and then we have where t is 0, that'll be e to the 0, which is 1. So this is from this. Now we have from this part minus 1 over 2 pi times 1 plus 2n times e. Now here t is going to be this, so then the lambdas cancel and we have pi. So we have minus I 1 plus 2n times pi, and then t is going to be 0, e to the 0 is 1, minus 1. Okay, now in each of these cases, we have, this is an even number added to an odd number. That's going to give us an odd multiple of pi. So this is going to be negative 1, because if you expand, and this also is going to be negative 1. Here we have an even number, so we're going to have 1 minus an even number. That will always give us an odd number. So we have an odd multiple of pi, and here we have minus an odd multiple of pi, but it makes no difference because what we have is cosine of 1 plus 2n times pi from up here. Here would be negative, but the cosine is an even function, so it's the same way either time. This is n now. And then we're going to have either plus or minus, depending upon which function we're working with here. There's going to be I times the sine of 1 plus or minus 2n times pi. And it makes no difference whether it's plus or minus, or this is plus or minus. This is going to be 0. Any multiple of pi, the sine of that function is 0. And this is always going to be an odd number here. The cosine of any odd multiple of pi is negative 1. So in each case, our exponential is just simply -1. So let's put that in. -1, -1. So -1 minus 1 is -1 plus -1. That's -2 multiplied by this. It gives us +2. And this goes away. And from here, we have -1 minus -1 is -2. This is +2. So there's our expression for C sub n, and the 2's also will cancel. So we get rid of this 2 and this 2. So we have 1 over pi, 1 minus 2n plus 1 over pi, 1 plus 2n. So let's, and we can factor out a 1 over pi from each one of these. So let's do that. We have C sub n equals 1 over pi times 1 over 1 minus 2n plus 1 over 1 plus 2n. Okay, so this will be equal to 1 over pi. This will be 1 plus 2n plus, cross multiplying over here, 1 minus 2n divided by this times this. So we have 1, cross terms drop out, and we have minus 4n squared. And these cancel. So, and up here we have 2, so this will equal 2 over pi, and then we have 1 over 1 minus 4n squared. So that is C sub n. Notice this is always going to be negative, and n is just 1. We have 1 minus 4. So we can write it like this. We can say C sub n will equal minus 2 over pi times 4n squared minus 1. And C0, if n is 0, we'll have negative pi down here times negative 1, so that would be plus 2 divided by pi. Okay, and then for the complex form of the Fourier expansion, we have f of t equals this summation and goes from minus infinity to plus infinity. So here what we can say for our problem, sine of that was lambda times t. We're taking the absolute value of this. This will be equal to C sub n, that's this, minus 2 pi times 1 over 4 n squared minus 1 times e to the I n, and omega naught, that was 2 lambda. So finally, there's our expression. Notice that if we have n is equal to 0, then we just have negative 1 here times minus 2 pi. It becomes plus 2 pi. And a 0, that's 1. So we have C of 0 equals 2 pi, which agrees with this up here. So we can combine all this into a single expression, and there it is. Okay, so that's it for this problem. Come back, join us in the next video. What we're going to do is consider a square wave. We'll try to expand it with the Fourier expansion for when the Fourier is in trigonometric form for the Fourier expansion, and then also look at the same type of problem when we're using the exponential form for the Fourier expansion technique. So come back, transfer those videos, and let's see if we can solve some more problems.